1940 night drill log. One chock missing, the Smith gun tipped loaded. Inspection marked a breech lock failure. The report was sealed before dawn. In 1940, Britain expected that an invasion attempt. Regular anti-tank guns were insufficient in numbers. Existing stocks were allocated to field formations. Home defence units received improvised anti-tank measures. Home Guard battalions guarded roadblocks and bridges. Many platoons lacked any dedicated gun equipment. German armoured vehicles were the assumed threat model. The procurement system faced immediate delivery pressure. Factories were already committed to priority ordnance. Skilled labour pools were under rapid wartime strain. Steel allocations were centrally rationed by ministries. Machine tool capacity was booked months ahead. Design bureaus were ordered to propose stopgaps. A low cost was treated as a primary requirement. Weight limits were set for light towing. Training burden had to remain minimal. The Home Guard workforce was mostly part-time. Older volunteers had limited heavy weapon experience. Any new system needed simple field handling. The invasion scare shortened evaluation timelines. Safety margins were narrowed by delivery schedules. Procurement boards accepted higher operational risk. A weapon could be authorized before full trials. That logic produced unusual emergency programs. One product was the Smith gun. Contemporary paperwork credited W.H. Smith as designer. Design review was handled by Home Forces staff. All-up weight was about 600 pounds. That mass defined towing and handling limits. It was a 3-inch smoothbore gun. It was issued mainly to Home Guard units. And its role was anti-tank at close ranges. It also offered limited indirect fire capability. The gun solved a specific supply gap, substituted for standard 2-pounder guns. It tried to provide mobile roadblock firepower. It did so with low manufacturing complexity. The solution relied on a tipping carriage. The carriage was also the transport chassis. Firing required rotating the entire weapon assembly. This procedure shaped every safety problem observed. The design emerged from emergency small-scale engineering. It was promoted through Home Forces channels. Official interest was driven by short lead time. The requirement allowed unconventional firing arrangements. The Smith gun fit that requirement definition. It looked like a trailer with a barrel. 2 large wheels supported a central gun tube. A small shield and platform sat above. In travel, the barrel sat near the axle. The unit could be towed by light vehicles. It could also be manhandled short distances. That portability appealed to Home Guard planners. The same portability created stability compromises. A typical crew was 3 or 4 men. Crew tasks were loading, laying, and towing. The crew also managed the tip-over process. This step was the defining hazard point. The first concepts existed as rough workshop prototypes. The concept emphasized minimal machining operations. The barrel was a simple smoothbore tube. The breech used basic block closure methods. The carriage used plate and tubular steel members. Wheels were from common industrial supply patterns. Fasteners were standardized to reduce unique parts. The design avoided complex recoil recuperators. Energy was managed by mass and movement. That choice reduced precision and increased disturbance. Initial trials focused on function, not refinement. Acceptance tests were accelerated by procurement urgency. Reports noted awkward ergonomics during crew drills. Handling problems appeared during tipping on uneven ground. The gun could roll unexpectedly during repositioning. Wheel brakes were limited in effectiveness. Ground anchors were not always used correctly. Some drill instructors forbade live loading during tipping. Other units continued the official drill sequence. Training variants increased accident probability greatly. Ammunition supply raised further constraints overall. The gun fired 3-inch projectiles. A separate cartridge provided propellant charge. The round was loaded from the rear. A firing pin struck the primer in the base. Ignition drove gas pressure into the smoothbore. The projectile relied on drag stabilization and shape. Spin stabilization was absent by definition. That limited practical muzzle velocity options. The anti-tank shot was a solid projectile. Penetration depended on impact of energy at short range. Effective engagement ranges were limited in doctrine. Many notes cite roughly 100 to 300 yards. For indirect fire, range was longer. Some manuals describe about 1,500 yards maximum. High elevation fire used the upright orientation. Direct fire used the side-tipped position. The tipped position lowered the axis of recoil. It also broadened traverse by rotating the mount. The weapon could be laid by moving the chassis. that imposed heavy physical demands on crews. The crew had to push against wheel friction. On soft ground, movement became unreliable. On hard roads, movement risked uncontrolled rolling. The breech mechanism was simple but unforgiving. Closure depended on correct seating of the block. Dirt or ice could prevent full lock. Partial lock increased gas leakage risk. Gas leakage threatened crew near the breech. The loading procedure required strict muzzle awareness. The muzzle could swing during carriage movement. The barrel sat close to ground when tipped. That complicated safe loading posture significantly. Miscommunication during drills produced finger injuries. Some reports mention crushing during tip-over events. The carriage weight could trap hands and feet. The tipping motion also risked sudden rotation. If balance was lost, the gun fell abruptly. That created the suicidal label in units. The label reflected training casualties and near misses. The design also had a unique firing geometry. Recoil impulse could shift the entire assembly. After firing, the gun could bounce or rotate. Wheel contact points changed under recoil load. Uneven surfaces amplified that movement sharply. Improvised chocks were often used in field practice. Chocks were not always available under stress. Doctrine required selecting a flat-firing platform. Home guard positions were rarely flat. Road verges sloped and were cluttered. Hedges and ditches limited carriage placement. The tipped gun occupied a wide footprint. That footprint was hard to conceal. Concealment mattered for close anti-tank work. The muzzle blast was obvious at short range. The low velocity reduced blast signature somewhat. It also reduced armor penetration at distance. The ammunition type influenced handling risk. Propellant charges were kept in separate containers. Moisture sensitivity required dry storage discipline. Home guard stores were often improvised structures. Some ammunition was kept in barns and sheds. Temperature swings caused condensation in cases. Condensation could degrade primers or charges. Misfires were reported in some training logs. Misfires forced awkward clearing procedures frequently. Clearing required opening the breech carefully. A stuck round increased danger during extraction. Extraction tools were not always issued. Units improvised with rods and levers. Improvisation increased risk of impact ignition. Safety circulars advised strict misfire wait times. Volunteer crews did not always observe them. The weapon was also used for demolition rolls. Some units planned use against road obstacles. And the gun could fire high-explosive bombs. HE rounds used fuses, detonators, then main charge. Typical bomb carried about 1 pound explosive filler. HE rounds posed fragmentation risk near crew. Fragment zones were difficult to estimate. Lack of indirect fire training increased hazard. Spotting fall of shot required observation posts. Observation coordination was not standardized in Home Guard. The gun therefore saw uneven employment styles. Initial allocations went to southern coastal defense counties. Home Guard anti-tank platoons listed them on roadblocks. Operational standby began during late 1940. Procurement records show limited production numbers. The system was never a mass battlefield standard. Output served mainly the invasion emergency interval. As invasion risk shifted, distribution slowed. The gun remained in some local defense areas. Reports from 1941 mention continued training use. By 1942, priorities had moved elsewhere. Standard anti-tank guns entered Home Guard inventories. PAAT distribution also reduced reliance on guns. The Smith gun began to be sidelined. Its mechanical design deserves close breakdown. The barrel was 3 inches internal diameter. Wall thickness was adequate for low-pressure loads. Pressure limits were constrained by smoothbore construction. The chamber accepted a fixed propellant cartridge. The cartridge resembled simplified artillery cases. Primer type followed British service standards. The firing mechanism used a striker system. A trigger released the striker onto the primer. Safety relied on mechanical sear engagement. External safeties were minimal or crude. Some trigger linkage could snag during handling. Snagging risk increased during carriage tipping. Some units added improvised guards and covers. These modifications were not officially standardized. The breech block required full rotation to lock. Lock confirmation depended on visual inspection. In low light, inspection was unreliable. Blackout conditions were common in coastal areas. Training sometimes occurred during night exercises. Night drills elevated accident rates significantly. The carriage had 2 large spoked wheels. Tyres varied by production batch and supplier. Some wheels used solid rubber tyres. Other wheels used pneumatic tyres for towing. Tyre choice affected recoil absorption characteristics. Pneumatic tyres increased bounce after firing, solid tyres increased transmission to the frame. Frame stress concentrated at axle brackets. Cracks were observed in some service inspections. Weld quality varied across contractors widely. Wartime welding standards were inconsistent in small shops. Inspection teams attempted to reject poor welds. Rework slowed delivery and raised unit cost. Cost remained lower than full anti-tank guns. That cost advantage drove continued acceptance. The gun's sighting system was rudimentary. A simple open sight was common. Fine adjustment screws were absent or coarse. Elevation was adjusted by shifting mount angle. Traverse was adjusted by moving the entire unit. This reduced accuracy in rapid engagements. Accuracy was less critical at short range. However, short range increased crew exposure. That exposure was the doctrinal trade-off. The anti-tank role assumed ambush positions, and crews were told to fire from cover. Cover options were limited by carriage bulk. In towns, the gun could be placed behind walls. In open country, concealment depended on hedgerows. Tipping the gun required space behind it. Space was not always available at roadblocks. Some crews pre-positioned the gun already tipped. That reduced reaction time but increased hazard. A tipped gun could shift in bad weather. Rain softened ground and changed support angles. Frost heave could lift one wheel base. Small changes altered recoil direction unexpectedly. The muzzle had a simple crown finish. No muzzle brake was typically fitted. Absence reduced complexity and blast side effects. It also allowed full recoil impulse to remain. Recoil management relied on chassis movement. The chassis could rotate around wheel contact. A rotation risked laying shifts between shots. Rapid follow-up shots were therefore difficult. Rate of fire was limited by repositioning. Loading was manual and slow under stress. Ammunition was heavy for older volunteers. The round length complicated passing through shields. Crew posture was constrained by wheel geometry. The breech height changed between orientations. This required different loading drills for each mode. Mixed mode drills confused novice crews. Command memos demanded standardized drill cards. Drill cards were issued but not universal. Local commanders improvised simplified drill orders. Simplification sometimes omitted key safety precautions. Safety precautions were written after incidents occurred. Incident reporting fed into revised instructions. Revised instructions reduced operational flexibility further. That reduced the weapon's attractiveness to planners. Testing documentation emphasized acceptable proof strength. Proof strength did not equal safe field handling. Field handling dominated the accident statistics. Accounts described the gun overturning on slopes. Overturning could injure loaders and layers. Some accidents occurred during towing to positions. Tow hooks sometimes failed under abrupt braking. A detached gun could roll on roads. Road accidents were reported in at least some counties. Restrictions were introduced on towing speeds. Restrictions limited rapid redeployment capacity severely. Redeployment had been a key selling point. The platform also limited depression angles. Against tanks, low depression could be problematic. Firing downhill from road banks was difficult. Crews sometimes dug shallow pits for wheels. The digging consumed time and drew attention. Pits improved stability but reduced traverse. The weapon therefore demanded prepared positions. Prepared positions were not always feasible. The Home Guard mission required flexible sighting. That mismatch reduced institutional confidence steadily. Still, some units reported effective practice shoots. Targets were usually derelict vehicles or plates. At close distance, solid shot could penetrate. Against early war light armour, effect was possible. Against later medium tanks, effect was uncertain. Reports rarely claim reliable kills anywhere. More often, they report mobility damage possibility. Track hits were emphasized in training. Track hits required precise aim and timing. The crude sights made this difficult. Therefore, crews were told to aim low. Aiming low also risked ground ricochet. A ricochet risk increased on hard surfaces. Road firing could produce unpredictable deflections. Deflection could endanger friendly positions nearby. Safety zones were hard to enforce. Home Guard training grounds were often small. Adjacent farms and roads constrained firing arcs. Range safety officers faced unusual responsibilities. Some ranges banned tipped firing entirely. Other ranges allowed only upright indirect firing. This split training produced inconsistent tactical skill. When the gun was deployed operationally, confusion followed. Operational deployment was usually static in defense belts. Guns were assigned to roadblock plans. Plans listed firing points and fallback positions. Map overlays often omitted the tipping clearance area. That omission caused last-minute site changes. Site changes delayed readiness (CUMEX) repeatedly. Readiness checks included ammunition inventory reconciliation. Ammunition allotments were small in many units. Resupply required requests through county stores. County stores had competing priorities and delays. Transport for resupply was not guaranteed. Therefore, crews sometimes hoarded ammunition improperly. Improper storage increased moisture and corrosion issues. Corrosion on cartridges caused extraction difficulties. Extraction difficulties increased clearing hazard again. The procurement bureaucracy responded with more paperwork. Ammunition cartons carried lot markings and dates. This burden landed on overstretched unit clerks. Clerks tracked losses and issued replacement requests. Replacement requests were often slow and incomplete. Delay increased reliance on local improvisation. Local improvisation increased divergence from central doctrine. Sites could be lost during towing. Replacement sites were not always stocked. Improvised sites were fabricated locally often. Improvised sites differed between units noticeably. This undermined standard range tables completely. Range tables were already approximate for smoothbore. Projectile drag varied with manufacturing tolerances. Fin alignment could vary in some bomb types. Variation changed trajectory and impact point. This reduced confidence in recorded firing data. Confidence matters in a low-margin weapon. Low-margin weapons require strict predictability. The Smith gun lacked that predictability. For field use, a typical drill followed. A tow vehicle placed the gun near position. Crew applied chocks and unhooked the drawbar. The crew then selected the desired firing mode. For anti-tank, the unit was tipped. 2 men pushed while one controlled the barrel. The gun rolled onto one wheel, face. The barrel then pointed across the roadway. Lay was adjusted by shoving the wheel rim. Elevation was set with simple wedges. A loaded round was then inserted. The breech block was then closed and checked. On command, the trigger was pulled. Recoil shifted the chassis slightly rearward. The crew then assessed stability and aim. If required, the gun was repositioned. This cycle was slower than standard guns. It also exposed crew repeatedly to movement. Movement near the muzzle increased accident risk. Accident risk was recorded as training losses. Training losses affected willingness to man the weapon. Willingness was monitored in unit reports. And some reports describe refusal without supervision. Supervision required experienced NCO involvement consistently. Experienced NCOs were scarce in Home Guard. Some were assigned to other urgent duties. That left inexperienced leaders on the gun. Inexperienced leaders made drill errors frequently. Errors were often corrected after incidents. The institutional impact was negative reputation. Silent deployment required pre-tipped concealment often. Pre-tipped concealment increased weather exposure substantially. Weather exposure increased corrosion and fouling. Fouling in the bore reduced accuracy further. Cleaning kits were not always issued in full. Volunteer crews improvised with rags and rods. Improvisation increased risk of bore obstruction. Obstruction could cause pressure spikes dangerously. The pressure spikes threatened barrel rupture directly. Rupture would be catastrophic at close quarters. This possibility was cited in safety briefings. Safety briefings often used strong language. Strong language reinforced the weapon's grim nickname. Nicknames influenced informal morale and compliance. Commanders attempted to counter with formal instructions. Formal instructions emphasized correct tipping procedure. They mandated chocks, clear zones, and signals. Signals reduced confusion but slowed engagement readiness. Procurement officers assessed whether benefits justified costs. By 1941, better alternatives were available. The 2-pounder supply improved somewhat. The 6-pounder entered broader service. Home Guard began to receive Piat launchers. Piats required less towing and less setup. PIATs also reduced crew exposure footprint. Therefore, Smith guns were less requested. Maintenance burdens also affected retention materially. Spare parts were non-standard across small contractors. Wheel bearings were a frequent wear item. Bearing failure immobilized the carriage completely. Immobilized guns could not be redistributed quickly. Workshops prioritized vehicles and radios instead. Guns waited for repair for long periods. Inspection schedules were therefore missed often. Missed inspections increased safety incident probability. Policy responses included withdrawal from some units. Withdrawal decisions were made at county level. Some counties kept guns for static use. Static use meant upright mode only. Upright mode reduced tipping accidents markedly. Upright mode also reduced anti-tank usefulness. Therefore, the weapon's main purpose eroded. The post-war assessment treated N as emergency expedient. It is cited as a pressure-built solution. It represented constrained manufacturing and urgent doctrine. It also showed the cost of shortcut trials. The Smith gun did not disappear immediately. Some were stored in depots after 1942, others were scrapped as a metal reclamation. Surviving examples entered museums and collections. The final evaluation is administrative and plain. Britain issued it because stocks were empty. Britain retired it when stocks returned. The Smith gun remains a record of that.